Hello students. In this session, let us discuss about the vehicular characteristics that will affect the safe and efficient operation of the traffic. Traffic characteristics includes road user characteristics and vehicular characteristics. Road user characteristics has already been discussed in the previous session. So now let us concentrate on the vehicular characteristics. Some of the vehicular characteristics which are concerned for a traffic engineer for a safe traffic design includes the static characteristics. Second one is the dynamic characteristics. So static characteristics are one, the parameters will not change at all. Whereas the dynamic characteristics, so the characteristics which includes the speed, acceleration, braking system, lighting, vehicle design, tire type. So these parameters, all these things will change according to the the condition of the road, the condition of the environment, what is the type of the surface, what is the speed that is required, etc. Now let us look into that. What are all the various characteristics which are very much essential for a traffic engineers. So the first one is the vehicle dimensions. What is the dimension of the vehicles? That can be the height of the vehicles, the maximum turning angle, what is the length of the vehicle. Also the other parameters are including what is the height of the driver's seats. So that will affect the visibility distance, what is the distance visible to the driver ahead of him, and also what is the height at which you have provided the headlights, so which is particularly important during the night time. So and when you travel in the valley curves or in the gradients, or you can call it as in the hill station. Okay, so especially, so what is that height at which you have fixed the headlight, that will decides the visibility during the night time under the headlights. And also the other parameter like the clearance between the edges, so that is very important when you design the road humps and dips. So when you design a hump, so that should be provided in such a way that so that will not hit the edges of your vehicle. So all these parameters need to be studied whenever you design any traffic facilities. So next static characteristics which is essential is the weight of the vehicles. So weight of the vehicles, that will decides what is the thickness of the pavement you have to provide. And next comes the dynamic characteristics. So within the dynamic characteristics, we need to study on the speed of the vehicles. So that's the most important thing. So why that is required, we'll study that in the further slides. So apart from the speed of the vehicle, so we have to study about the braking characteristics. What is the type of the brakes provided in the vehicles, what is the efficiency of the brakes we have. So all those things are important to be considered. And also we need to study on the power of the vehicle, power performance of the vehicle, so which is essential whenever the vehicle travel in the gradients, what is the power of vehicle. And also the another important parameter is the off tracking. So all these need to be considered as a very important parameters with respect to the vehicles for the design of the any traffic facility. So Veneers will look into one by one, and also will study on the what are the IRC recommendations. So whenever we talk about the standards, all the standards are given by the IRC, Indian Road Congress, for the design of any traffic facilities. So the condition required for the weight of the dimension of the vehicle, weight, the speed, so all these, how to provide the off tracking, what should be the braking efficiency, what should be the minimum power required for the vehicle. So all these are given by the IRC, Indian Roads Congress. So in the further slides we'll look into the what is the importance of each and every characteristics and what does the code says recommendations made. So we'll study in that in detail. So the first vehicular characteristics is the vehicle dimension, so which will includes what is the overall width of the vehicle, what is the length, and what is the height of the vehicles that need to be provided for the different category of the vehicles, that will significantly control so many of the geometric elements of the highway. So width of the vehicles, so why it is important, why we need to consider the dimension and where it will come into picture. So mainly the width of the vehicles is required whenever you want to decide the traffic lanes. For example, so this is your width of the road that is available. So now here the width of the vehicles what you design should be such that you should have a side clearance and you should provide a maximum capacity of the road has to be achieved. So now here whenever you decide how much should be the number of lanes that you have to provide, what should be the shoulder widths you have to provide. So all these things will be based upon the what is your width of the vehicle. And also whenever you design the parking facilities, how much should be the width of the parking lane you have to provide. Okay, so what's the dimension of the parking space that you need to reserve. So all this depends upon the width of the vehicle. And the next one we have the length of the vehicle and length of wheelbase. Okay, so now so in the length of the vehicles is required whenever you design for the horizontal curves or the curves at the place of curves, what should be the radius you have to provide. Okay, and also what is the overtaking distance, what is the overtaking distance that is required during the overtaking operations, and also parking of your vehicle. So similarly how the width is important, so when you fix up the any parking space, so we have to look into the length of the vehicles also. And the next one is the height of the vehicles. So where it will come into picture, where it is essential. So height of the vehicles is very much essential to be considered whenever you provide the clearance in the under structures. For example, that can be a bridges or in the under bridges or the over bridges. And also whenever you take up your electric lines or any cable lines, okay, there should be a sufficient clearance between your vehicles and those electric lines. Okay, so there it is very essential to consider what is the maximum height of the vehicles that is allowed in that particular height. And also the overall gantry signboards, the signboards which is taken across the roads. Okay, so when you decide what should be the height at which you have to provide that signboards, that was decided based upon the maximum height of the vehicle expected in that particular road. So now let us look into what are the IRC recommendation, what Indian Road Congress says on width of the vehicle's height and the length of the vehicle. So invariably width of the vehicles for all category of road is restricted to 2.5 meters in India. So no vehicle should not be greater than the width of the vehicle should not exceed 2.5 meters. Almost all the category of the vehicles, the width will be the maximum allowable width will be designed for 2.5 meters. And now the height of the vehicles, that depends upon whether it is a single decked vehicle or a double decked vehicle. So maximum permissible height for the single decked vehicle is 3.8 meters and for a double decked vehicles can go up to 4.75 meters. And coming to the length, so length of the vehicles, that depends upon what is the number of axles that have been provided. So if it is any vehicle is single unit truck with 2 or more axle, the length is restricted to 11 meters. A bus 12 meter, semi-trailer tractor 16 meter, and the tractor and trailer combination, the length can be increased up to 18 meters. So whenever you design any vehicles, you need to keep these recommendations in mind, and no vehicle should exceeds the dimension what is given by the IRC recommendations. The second vehicular characteristics which is important for the design of the traffic facilities is the weight of the loaded vehicles. So nothing but what is the weight carried by the vehicle. So why it is important? So what is the weight carried by the vehicles, that will design the pavement thickness. What is the thickness of the pavement that need to be provided. And so what is the weight carried by the various category of the vehicles, that depends upon the number of axles that has been provided. So as you increase the number of axles, the load carrying capacity of the vehicles can be increased. So first let us look into that, what is an axles. So axles are nothing but the central staff to which your wheels or your rotating part will be attached. Okay, so as you can see in this picture, okay, the vehicles will have the steer axle, so that is nothing but the front axles and also the rear axles. So when you increase the number of axle and the rear end of the vehicles, so that will increase the load carrying capacity of the vehicles. So depending upon the how many number of axles that are provided in the rear end of the vehicle, IRC has given the various value, the recommendations, the limitations values for the various category of the vehicle. If the vehicle is carrying a single axle, having a single wheel, so the maximum load carrying capacity is restricted to 6 ton. Similarly, if you have the tandem axles, the maximum legal axle load is 18 tons. And also if you have a single axle load with the dual wheels, so load carrying capacity is 10 tons, and if you have trident wheels, the load carrying capacity can be increased up to 24 tons. So I have confused what is a single axle, multi axle. So the typical passenger car is an example for the single axle vehicle, so which is having a load carrying capacity of 6 tons. So you can see here the single axle, there is only one axle and one wheel. Okay, so this type of vehicles you call it as the single axle with single wheel. Okay, so the second category we have the single axle with two wheels. So you can see there is the number of axle is only one, whereas you have two wheels attached to the each and every side of your axle. So for this particular type of vehicles, the load carrying capacity is 10 tons. Whereas the tandem axle, so you will have two axle attached adjacent to it. So this you will call it as the tandem axle. If you have two axles at the rear end of the vehicle, you call that as the tandem axle. So for the tandem axles, the load carrying capacity is 18 tons, and the trident, you call it as a trident axles when it is provided with the 3 number of axles. So for the trident axle, the load carrying capacity can be increased up to 24 tons. So as you can see here, whenever you increase the number of tires or number of wheels, okay, the load carrying capacity of the vehicles will be increased. That is because of the reason that you will have a greater contact area for distributing your wheel loads. Okay, so hence whenever you increase the number of axles, the load carrying capacity of the vehicles will be increased, and you should ensure that the load carried by any vehicle is not exceed these values which are given by the IRC recommendations. So the next characteristics which is essential is the speed of the vehicle. The speed of the vehicle is the one which will control all geometric elements of the roadways. So anyways, all these geometrics, the design or explanation related to that is not included in the syllabus. So but you should be knowing where it will come to picture. So that is used in the designing the side distance. Side distance is nothing but the what is the distance required for you to stop the vehicle. So that will depend upon the speed. Higher the speed, greater will be the distance required for you to stop the vehicle. Or if the speed is very less, within no time, within no gap, you can stop your vehicle immediately. And also in the curves, so at the curve, what is the super elevation that has to be provided, what is the radius of the curve you have to provide, and also what is the length of the curve that has to be provided, that will depend upon the speed of the vehicles. So apart from this also, so what is the width of the vehicles, the traffic lane, what is the width you have to provide, what is the width of the shoulders you have to provide, the gradients nothing but the slope at which you have to lay out road. So and also the maximum capacity of your traffic lane depends upon the speed of the vehicle. And also the design and control of intersection. So at the place of intersection, maybe providing the signals or providing the rotary intersections. All these are providing a channelization. All these parameters will be dependent upon the speed of the vehicle. Once again, he has recommended the standard values. What should be the speed of the vehicles for various categories. So here the classification is based upon, the first is the terrain condition, second one what is the category of the road. So terrain condition is nothing but what is the general slope of the area. Okay, so based upon the general slope of an area, we can classify the terrain condition into four categories: the plain, rolling, mountainous, and the steep terrain. Okay, so plain terrain, and also based upon the various category of road, you can classify the roads as national and state highway, major district road, or you can call that as MDR. Next, other district road, you can call it as the ODR, and the VR, village roads. So now based upon the terrain condition and the category of the road, IRC has recommended various speed value. So here you can see we have something called rolling speed and the minimum speed. So rolling speed is nothing but the maximum allowable speed in that particular category of the road. The minimum speed is the what should be the minimum speed you have to follow when you travel in that particular road. So we'll look into the one example. So for if the category of the road is national highway and you have such highways in the plain terrain, the speed limit is in between 100 to 80 kmph. Similarly, for the same particular highway, if it is the rolling terrain, the slope is slightly increased, so the speed limit is reduced, that is in between 80 to 65 kmph. And in the mountainous terrain, still they will have restriction to speed. It is in between the 50 to 40. So if the terrain condition is very steep, the speed is restricted to 40 kmph. Like this, we have the various speed limit standards for the other category of roads also. The next dynamic characteristics of vehicle is the braking characteristics, which is need to be considered in the design of the traffic facilities. So why it is required? The deceleration or the braking characteristics, that depends upon the what is the design we have provided and what type of braking system is being provided, such as the mechanical or the hydraulic brakes. And also, so braking characteristics depends upon the what is the efficiency of application of the brakes. So where it is required, why do we require the braking characteristics? So mainly it is important when you consider the safety of the vehicle operation. So you should have a very efficient brake. So whenever you come across with the any conditions, the hazardous condition, you may have to stop your vehicles immediately. Only if you provide a proper braking system with a good efficiency, you may avoid such accidents. And also it is required for you to decide what should be the stopping distance that is required for you. So whenever after application of the brakes, so vehicle will move to a certain distance before it comes to the stop. What is the distance the vehicles have moved after the applications of the brakes, that you call it as the stopping distance. So that stopping distance is decided based upon the what is the type of the braking system that you have provided in a vehicle and also its efficiency. And also when maintaining the space between the two consecutive vehicles, so there also you require the braking characteristics and also the efficiency of the brake. Almost the highway capacity and the overtaking side distance requirement, that also directly affected by the acceleration and deceleration characteristics of vehicles as well as the braking characteristics. As I already mentioned you, after application of the brakes, your vehicle will move to a certain distance before it comes to stop. So what is the distance the vehicles have moved? Nothing but that the stopping distance, that depends upon the two parameter. One is the what is the braking characteristic, what is the type of the brake that is provided and also the efficiency. The other parameters which is also influencing on the stopping distance is the skid resistance of the pavement surface. When you apply a brake, what is the resistance that is developed by your pavement surface, that will also decide your stopping distance. So what is that skid resistance of the pavement surface under the prevailing condition or for various speed condition can be determined with the help of the braking test. Okay, so now whenever, and also one point to keep it in mind, whenever you apply a brake, if the vehicles are completely locked and it comes to stop immediately, then you call it as the brake efficiency is 100%. Okay, and here, so if you want to measure the skid resistance of the pavement surface, you should be knowing any one parameter, or else the first is the after application of the brake, what is the distance the vehicles have moved before it has come to stop. That distance is required, nothing but your braking distance. We will represent it with the letter L. It's measured in terms of meter. And the next parameter which is required is the initial speed. What is the speed at which the vehicle is traveling before the application of the brakes? Or you should have a detail about the what is the acceleration of your vehicle, rate of acceleration of the vehicle. That is in terms of meter per second square. They are represented by letter A. So if you have any two data among these three, either the braking distance, initial speed, or the acceleration. So if you have any two data among these three, you can determine what is the skid resistance of the pavement surface. With the help of braking distance L, initial speed U, and the acceleration A, so you can measure what is the skid resistance of the pavement, that is denoted by the letter F, using some of the following relationship. So now we have a relationship between the length, or nothing but your braking distance, and the coefficient of frictions or initial speed, that is L is equal to U square divided by 254 F. So here when you use this particular formula, you need to be careful that the U has to be taken in kilometer per hour, or else we have other formula L is equal to U square divided by 2G, I'm sorry, this is F, 2GF, so where U is in meter per second. Okay, so the second relationship, we also have the skid resistance can be measured using the acceleration. On the if you have acceleration, you can measure it. F is equal to A divided by G. So where A is the acceleration of the vehicle and G is the acceleration of due to gravity, that can be taken as 9.81 meter per second square. So this expression is derived using the fundamentals of the physics equation. F is equal to mass into acceleration. Okay, so we have derived using that, and also the other two relationships which will gives you the relationship between the initial speed, acceleration, and the braking distance, or V is equal to U plus AT, V square minus U square is equal to 2AS, where V is the final speed. The final speed will also always be 0, because after application of the brakes, the vehicles will come to stop. That's why we will take final speed into 0, and initial speed is the speed at which vehicle was traveling initially. And whereas yes is nothing but L, that is the braking distance in terms of meter. So T is the time taken for the vehicles to come to stop after application of the brake. So remember these equations. So we will solve the problems to determine what is the skid resistance developed by the pavement surface. The last characteristics of vehicles which is essential for the design is the off tracking or mechanical widening. So let us first understand what is an off tracking or why we require mechanical widening. So this will come to picture only when your vehicles travel in the curves. So I think you might have noticed at the curve. So usually this is the width of your pavement, approaching pavement. So here at the curve portion, so your width will be slightly increased, W dash. Okay, so this is nothing but your mechanical widening. So why it is provided? Why the width is increased here? So usually whenever your vehicle will travel along the curves, so centrifugal force will be developed, so that which will pull your vehicle out in the outward direction. So to counteract the centrifugal force, we will provide super elevation and transverse skid resistance. Okay, so to counteract the centrifugal force developed whenever the vehicle travel along the curve, the super elevations will be provided, as well as the transfer frictions will be provided. So whenever at relatively lower speed, when the centrifugal force developed is lesser than the contracting force due to the super elevation and the transfer friction, the rear wheels follows the path inner side of the horizontal curve as compared to the path followed by the corresponding set of front wheel, as you can see in the picture here. So now to avoid the vehicles coming out of your pavement surface, you need to increase the width of the pavement at the curve portion. So that increased width, we call it as the mechanical widening. So what is this phenomenon? So where the rear end outer wheel will follow the inner side of the curve compared to the front wheels of your vehicles, that you call it as the off tracking. Okay, so whenever the increased width at this curve portion is termed as the mechanical widening. How much should be the width has to be increased? That you will given with the expression L square divided by 2R, where L is the length of the wheelbase. So from front to the front rear end wheel to the front wheel, what is the distance? So that you call it as the length of the wheelbase. And also that the off tracking is depend upon the what is the turning angle or the radius of the horizontal curves. With this, I will conclude this session, and in the next session, let us solve some of the numericals which is based upon the braking test. Thank you.